one thing, if we add a constant to each, then the newly formed numbers will not be in any progression. That is equal to x to the power b minus c. From here we get x to the power c minus a by 2, z to the power c minus a by 2 into z to the power a minus b. You have to show or find whether 640 will be in the GP series 5, minus 10, 20, ... I am going to discuss few necessary information. For AP, first for AP. Actually, these are the properties I have not discussed yet. That is why I am going to discuss these. Given numbers are in AP, then if we add a constant number to each, what will happen? Will those newly formed terms will be in AP? Or if we subtract a constant number from each, then the results will be also in AP, etc. I take the general form. A plus D, A plus 2D, ... Now add a constant. That constant may be positive or negative. Then what will happen? Let us see. Adding a constant K to each term, A plus K, A plus D plus K, A plus D, A plus 2D plus K, each term is increased by K. Now, if we find that the difference between two successive terms a constant, then we can conclude that the newly formed terms will be in AP. Remember, this K may be positive or negative. The constant may be positive or negative. Therefore, TR plus 1 TR. I take difference between R plus 1th term and Rth term. What will be that? A plus RD plus K. R plus 1th term, that means coefficient of D will be 1 less than that, minus A plus R minus 1 into D plus K. If we simplify, what we get? K cancel, A cancelled, therefore RD minus RD plus D, that means D. What we find? The difference between two successive numbers is same D. For this arithmetic progression, common difference is D. Here is also D. Therefore, the newly formed numbers or terms will be in AP. Therefore, A plus K, A plus 2K, A plus 3K, sorry, A plus D plus K, A plus 2D plus K are in AP. This is one property. Then next property, if we multiply each by a constant, if each term is multiplied by a constant, that is constant that is AK A plus D whole into K A plus 2D whole into K, like this. Now the question whether these numbers will be in AP. We now find the difference between two successive terms. What we find here, TR plus 1 minus TR will be equal to A plus RD into K minus A plus R minus 1 into D K. Now if we simplify, what we get? AK will be cancelled, R dk minus R dk plus dk. Result is dk. D, that is the common difference of the given AP, and K is the given constant. Then we find that difference between two successive terms is dk, which is also constant. Therefore, the conclusion will be these newly formed numbers are in AP. Therefore, AK A plus D whole into K, A plus 2D whole into K are in AP with common difference is equal to dk. Thus, if we multiply, we are multiplying by k, that may be greater than 1 or less than 1. If k is less than 1, that means we are dividing, and the newly formed numbers will also be in AP. Now these are the properties related to AP. Now properties related to GP. number 1. We take the general form ar square, ar cube. Now if we multiply each by a constant number, one thing, if we add a constant to each, then the newly formed numbers will not be in any progression. That is very easy, you can check yourself. If we multiply each by a constant number, that means if we divide each number or each term of GP, matter will be same. What we see, multiplying each term by k, a constant, we get ak, ark, ar square k, ar cube k. Now we take the ratio of two successive terms, t2 by t1, ark by ak, or t3 by t2, ar square k, ark, that is also r. Similarly, if we take a r to the power n minus 1 into k, a r to the power n minus 2 into k, the result will be same, r. That means ratio of two successive terms is always constant. Therefore, the conclusion is the newly formed numbers are in GP. Now, already I have told k may be greater than 1, less than 1. When greater than 1 means we are multiplying by a number which is greater than 1. When k is less than 1, that means we are dividing each by a number. In both the cases, the newly formed numbers will be in GP. Now, let me discuss few problems related to GP first. Now I am going to work out sums on AP and GP. I have taken this sum first, where ABC are in AP and XYZ are in GP. Therefore, we have to show this one. Solution: ABC are in AP. Therefore, 2B equal to A plus C. Also, X, Y, Z are in GP. Therefore, Y square equal to ZX. Now I calculate the left hand part. LHS is equal to x to the power b minus c into y to the power c minus a into z to the power a minus b. That is equal to y square equal to zx. Therefore, I can take that as x to the power b minus c into y square whole to the power c minus a by 2 into z to the power a minus b. Y square whole to the power c minus a by 2. On simplification, it will be y to the power c minus a. Now I put the value of y square there. X to the power b minus c into zx to the power c minus a by 2 into z to the power a minus b. That is equal to x to the power b minus c. From here we get x to the power c minus a by 2, z to the power c minus a by 2 into z to the power a minus b. Now this is equal to x to the power, powers will be added, 2b minus 2c plus c minus a into z to the power c minus a plus 2a minus 2b divided by 2. X to the power, we calculate 2b minus c minus a. 2b minus c minus a divided by 2 into z to the power, it will be a minus 2b plus c, a minus 2b plus c by 2. We have got 2b minus c. From here 2b minus c minus a equal to 0, or a plus c minus 2b equal to 0. That means both powers 0. X to the power 0 into y to the power 0, 1. That is RHS. Next sum, if a to the power 1 by x is equal to b to the power 1 by y is equal to c to the power 1 by z, and a, b, c are in GP, then you have to show these are in AP. Given a to the power 1 by x is equal to b to the power 1 by y, c to the power 1 by z. If I take each b k, then a will be equal to k to the power x, b will be equal to k to the power y, c will be equal to k to the power z. Actually, a to the power 1 by x is equal to k. To get the value of a, we have to raise to the power x. From that, a to the power 1 by x whole to the power x equal to k to the power x. That means a equal to a to the power 1 by x into x, x cancelled, therefore this one. Therefore we can write directly this one. Now given ABC are in GP, now A, B, C are in GP. Therefore, B square is equal to AC. Now I put the values of ABC here. Therefore, K to the power Y whole square is equal to K to the power X into K to the power Z from where K to the power 2Y is equal to K to the power X plus Z, from where we get 2Y is equal to X plus Z. Therefore, X, Y, Z are in AP. Already we have learned that if ABC be in AP, then double the middle will be equal to sum of the extremes, that is A plus C equal to 2B. Therefore, the sum is solved. Then sum number 3. Can 640 be any term of the GP? You have to show or find whether 640 will be in the GP series 5, minus 10, 20, dot dot dot. We start like this. Let 640 be nth term of 5, minus 10, 20. Here A is equal to 5. First term 5, common ratio is equal to minus 2. Therefore, nth term Tn, as per formula it is A r to the power n minus 1. I put the value 5 minus 2 whole to the power n minus 1. Therefore, 640 is equal to 5 minus 2 whole to the power n minus 1, or minus 2 whole to the power n minus 1 is equal to 640 by 5. Now, this can be written as 2 to the power 7 or minus 1 whole to the power n minus 1 into 2 to the power n minus 1 is equal to 2 to the power 7. We can take From that, n minus 1 equal to 7, that means n equal to 8. Now for n equal to 8, for n equal to 8, we see 2 to the power 7 equal to negative. Minus 2 to the power 7, that means negative. But 2 to the power 7 cannot be negative. Therefore, we can't get here a value of n for which nth term will be 640. Therefore, 640 is not a term of this GP 5 minus 10 20 dot dot dot.